All right, next up, Garrett Nowak from 1111 Systems. I think I'm speaking for both of us when I say Garrett's talk proposal just stood out to us from day one. Garrett's a new name to us, 1111 was a new name to us. I'm learning a little bit more about both, especially Garrett's sense of humor. I think you're really going to enjoy what you're about to see. So Garrett.
Just when I get it started, just sit here.
Wait a second, let me just make sure.
All right.
I want. Okay, it's ready.
So just click this one when I'm ready? Okay, cool. All right, hey everyone. My name is Garrett Nowak. I'm the Senior Director of Network Architecture at 1111 Systems. Quick context, 1111 is a cloud and connectivity provider, so we do things like infrastructure as a service, disaster recovery as a service, managed network services, things like that. So I'm here today to talk to you about how we went from having no network automation to having the majority of our tasks automated in under a year. So I'm not a network automation expert. I'm just here to share the story of our journey, and then maybe you'll have a takeaway to help you on your journey. Oh, the audio is not playing. Oh, there it goes. All right, so square one, this is where we started off with no network automation. I just kind of want to paint a picture of where we came from, and then I'll explain how we overcame some of our problems. So real quick, monitoring. We used SolarWinds, NPM, and NCM. It handled all of our alerting, monitoring, configuration, backups, things like that. How do I advance it? Okay, thank you. Change control, there really wasn't any change control. Engineers were trusted to not break the network. And then, you know, if you had time to document what you did, you did. Otherwise, you just moved on. For asset management, everything in our infrastructure was monitored in different systems, right? So we had a DSIM system separate from our IPAM system, separate from monitoring, and then none of those talked. And then, like somebody has mentioned earlier, we had configuration templates, but they lived on our laptops. You know, it was, hey Garrett, do you have a template for that? No, sorry, you're on your own, that type of thing. We didn't really have a central location to share the templates, and then, you know, we made templates if we had time, but if we didn't have time, you just, you know, started from scratch. Real quick, a breakdown of the actual systems. So again, SolarWinds for alerting, monitoring, and configuration backups. We used Inlight for our DSIM tool, 6Connect for our IPAM tool, and then we used Cacti BMS for all of our bandwidth monitoring. Before I jump into you know, the issues that we saw and everything, I wanted to give you all an idea of what our configuration change process looked like. As ugly as it is, I'm here to share what that looked like. So again, we started with a template. If we had a template to do something, we used that. Otherwise, we started from scratch. And then we configured the device. It was all manual, no surprise there. Everything we did was manual. Our change control was send an email to a distribution list. So, you know, if you remembered to send it to a distribution list, great. We saw it whenever we checked our email, but we had no visibility into things that were going on in the network. Like I mentioned, we updated all of our systems manually, so this was like after you pushed your config, you started the mind-numbing task of logging into every single system and updating it. There were times where when things were on fire, you didn't update these. You hoped you updated these, but sometimes you just didn't have time or whatever excuse there was. And then to wrap it all up, SolarWinds would back up the device config within 24 hours. Now, our major issues should be pretty obvious. We had multiple sources of truth, and this was the biggest headache for me. This is like where all of my stress and my job came from, because at the time, if I saw something in one system and then it was represented in another system, I didn't know which system was correct. And it's something that I dealt with every single day, and having to do a job where everything you do, you're unsure of if that is the correct thing to be doing is extremely stressful. My formatting is a little messed up, but we had uncoordinated systems. So again, I mentioned this earlier. This is pretty obvious. Every time we wanted to document what we were doing, you had to go log into 5 different systems, and none of them talked to each other. They were all completely independent of each other. We had a lack of visibility. So again, if you weren't working on the change yourself, you probably didn't know about it. If you had your email up at the time and you got a little pop-up that said somebody made a change, good for you, you caught it. But other than that, if you weren't doing it yourself, you probably didn't know about it. And then again, manual changes. Everything we did was manual. You name it, we did it by hand. One of my teammates calls it hand jamming, and we were hand jamming experts at this point. All right, so the first thing we did was we sat down when we decided to take on this project. We sat down and decided that we wanted to define core concepts. So as we went through this journey, if we ever got off track or we needed to reset or we argued about something, we wanted to have some core concepts that we came back to that we could point at and say, look, we all agree that these are our core concepts, so let's have our core concepts drive where we're going here. So the first thing for me was single source of truth. I talked about the multiple sources of truth being a daily stressor for me. If this project was a complete failure and I only got one thing out of it, I wanted it to be a single source of truth. That would have made me happy if we only got the single source of truth out of it. Building on top of our single source of truth, we wanted to take it one step further and have that be our centralized management. So if we have a single source of truth, and the information in that single source of truth is undeniably accurate, I should be able to enter information in my single source of truth and have it push all of that information out to my other systems. I don't want to have to go and log into 10 different systems. If I have a single source of truth and I know that it's valid, it should be updating everything for me. And this last one here is a bit abstract, but we hold a very high bar for ourselves on our team. That's something that we carry with us every day. Executives, other teams, they aren't as critical of us as we are of ourselves. So we knew that we wouldn't be able to design something that had 0 mistakes, but we could definitely try to design something that has 0 mistakes. So this materialized as wanting to build in things like quality assurance checks, test suites, things like that, so that when we were pushing things with automation in our infrastructure, we could be confident that we had the impact that we expected. After we defined our core concepts, we got a list together of, I see my formatting is messed up, sorry about that. After we got our core concepts figured out, we decided to go ahead and get a list of systems that we needed in order to take this from a core concept phase into actual production. So we didn't list vendors at this point. It was just, hey, what do we need in order to get from a theory to actually having this in production? So real quick, I'll just read these off. We decided we needed something to monitor our network devices and gather all the data. We needed something that would display the data. DSIM and IPAM are 2 obvious ones. We identified that we needed something for project management. We needed something to back up our configurations, and then we needed something to be able to communicate effectively with each other. All right, so major issues during our planning phase. The biggest one was uncertainty. So I had never done this before. Nobody on our team had ever done this before. So sitting there and talking about going from this theory to, hey, we're actually going to like put our money where our mouth is and put our jobs on the line and say like, hey, this is going to be the thing we're rolling. There's a lot of uncertainty with it. It happens in every project, right? Where you plan the project on paper, but what you put into production might not always be exactly what you had on paper. We were really scared of that, especially having to go to executives and say, hey, yeah, this will definitely work, and then like not really knowing if it's going to actually work. So uncertainty was a big thing for us. And scope creep here was intense. So it was really easy for us to sit down and say, let's do all the things, but we had to make sure that we identified the things that were absolutely vital to getting initial launch of this versus everything else that we could do further down the line. One of our biggest issues was config drift. So, we would have devices in our network, and then a couple of years later, we would find a better way to do something, or we would implement new processes and things like that, and we would never come back to our old devices and update them based off of the new way that we wanted to do something. So one of the big issues that we tried to solve for in this is not only do we want easy deployment of our devices, but we want easy maintainability. Because if our company is going to grow at the scale that we expect it to, there's no way that we can have the type of config drift that we initially had. So long-term maintainability was a big one for us. And then an obvious one here is buy-in, right? So this takes time and money to do this stuff. Even if you go open source like we did, we operated on an extremely low budget. But even if you go open source like that, you still have to commit time and like you are paying people salaries to work on this type of thing. So, and that's a hard sell for executives. We solved for it by spending a ton of time in our planning phase and then converting that into a clear and concise pitch to our executives. No bullshit, just get right to here's what we think we can do, and this is our plan. And that worked for us. All right, so we came up with Autonet, and my font didn't carry through, but just pretend that the Autonet is in a really cool font. We expected this, and we were right that we quickly found out we needed a centralized server for everything. So I've heard this talked about as the orchestration piece of it, and I had never put that vocabulary term to it before. Again, I'm pretty new to all this stuff. So orchestration, we needed something that was the brains behind it. And so we created Autonet. That's where we develop all of our automation. That's what facilitates communication between all of our systems. That's the brains behind the entire thing. So we knew what systems we wanted, or we knew what problems we were going to solve with our systems. So now it was just a matter of, hey, we have this thing we need to solve for. Let's go figure out what system can do that for us. I'm sure all of these are familiar to y'all, but I'll run through them just real quick. We use Slack for all of our team communications. Autonet, again, is the centralized server that we built to handle all of our orchestration. We use PagerDuty for a combination of low urgency and high urgency alerts. If it's low urgency, that means we need to get to it not right now, and high urgency is drop what you're doing and fix it. We use Prometheus for all of our monitoring. We use Bitbucket for our code repository, Jira for our project management. Grafana displays all of our Prometheus data. We use Netbox for DSIM and IPAM. Confluence handles our documentation, and we chose Unimus for our config backups. All right, so here are a few example workflows of what we do today. I just want to go through and kind of show y'all what we're using automation for right now, and then maybe that'll spark something in your brain for your journey here. So this is a new device workflow. This is adding a new device to our infrastructure. Right now, Prometheus is our single source of truth, which you'll soon learn we're changing because that was a mistake we made. But we add a device to Prometheus as our startup right now. So a device gets added into Prometheus, and then Autonet sees a change that happens in Prometheus, and it updates our entire infrastructure based off of that change. So this is where the brains of the orchestration come in. Now, some of those systems, Grafana, as one of its core features out of the box, will watch Prometheus. So as soon as a device goes into Prometheus, Grafana is immediately displaying metrics on it. But some of the other systems that I noted here, Unimis and Netbox, Autonet will send an API request to both of these systems. So for Unimis, again, that handles our config backups. Autonet will just send an API request to Unimis and tell it that there's a new device on the network. Unimis will add it to its inventory and then immediately go and back up the device for us. A bunch of the really cool stuff happens with Netbox. So Autonet will send multiple API requests to Netbox. Here's a good example of what we're doing in Netbox. So we use the SNMP location string on our devices to tell us the physical location, the data center, the suite, the rack, the RU, all that information we put in our SNMP location string. And when Autonet sees that a new device is out there, it takes that SNMP location string and parses it and sends the data to Netbox. So Netbox will, build the rack if it doesn't exist. It'll build the device, rack the device, and then it scrapes things like serial number, make and model, firmware version, IP addresses, all that, and it'll populate the DSIM and IPAM portions of Netbox for us. All right, here's a new configuration workflow. So we talked about the original one. This is what we do today. It starts off with providing Autonet with some parameters, right? Autonet doesn't know what we want to deploy. It can't read our minds. So we have to provide it an initial list of parameters for what we want to do. It'll generate a config for us, and then the engineer who initiated that will do a QA there on the spot. We had Jira, there's a little caveat to this one. We had Jira as a legacy system. So at the time that we went through this project, we decided to leverage Jira since we already had it as part of our workflows. Jira we use for long-term change documentation. So, we send a copy of all of our changes to Jira so that people outside of our team can query the things that we do, and they are aware of what's going on in our day-to-day. So once we review the config and determine that it's valid, we put the config in Jira, and there's some Jira automation that we use. So like when somebody puts a config into Jira, they can submit it for review, and that'll ping our team in Slack and let everybody know, like, hey, there's something that needs to be reviewed. When that gets reviewed, they'll change it to accepted, and it goes back to the person that is going to be pushing the change, and they go ahead and push the config. When they push the config, they mark the change as pushed, and that notifies us in Slack that something has been done to the infrastructure. That's an immediate notification as long as, you guessed it, as long as the engineer is properly timing the, hey, I pushed this. So there's still a gap there that we're working on fixing. Finally, Unimis does hourly scans of our network. So when it sees something has changed in the network, it'll send a diff to Slack so we can see, hey, this is what changed and here's the actual impact it had. So at worst here, the goal is we're notified immediately when somebody pushes a change, and if that gets missed, at the worst, we'll know within an hour what just changed in the network. Okay, so we talk about deployment all the time, but we want to also be addressing things like troubleshooting. So as a managed network services company, as an IaaS company, we deal with ISP connectivity a lot. One of the big issues that we noticed all the time was when we're managing these circuits and dealing with BGP issues with our upstream providers, there's a ton of manual stuff that goes into this. So like for us at square one here, I'm going to compare these side by side so that you can see how this evolved for us. But at square one, a BGP session flaps and somebody picks up on it. If it flaps once, we'll probably leave it alone. If it flaps multiple times, we'll probably shut the BGP session down. It's kind of just at the discretion of the engineer at square one. It's whatever you feel like is going to work, great, do that. So we go ahead and shut the BGP session down. We're notifying the ISP, hey, we have an issue with our circuit, things like that. And then we're just working with the ISP and waiting until we have the okay from the ISP to turn the circuit back up or turn the BGP session back up. And at that point, you hope that they were right and that all the issues are gone. So with our current design, we start again with the BGP session flapping, but at this point, we don't do anything. So our router automatically adds prepins to that circuit. So the goal here is just to make our AS path look undesirable to the internet, but still available while we troubleshoot the issue with the ISP. When a BGP session goes down, Prometheus will also notify us in Slack and PagerDuty. So Slack, our entire team gets the notification. They know that something's going on in our infrastructure with our upstream providers. And then PagerDuty will send a low urgency notification to our on-call engineer. So at the very worst, somebody is responsible for this. And here, if you look at these two, on the left, it's all manual intervention. On the right, the only thing we've done at this point is email the ISP and let them know that we saw an issue. You know, this reduced a ton of work for our on-call engineers because they're not getting woken up at 2 o'clock in the morning every time a BGP session bounces. You know, we're able to deal with those types of after-hours alerts and things like that automatically, and then Autonet will generate a report on network events that happen over a 24-hour period, and we can check that. You know, grab your coffee and log in the morning. And if you see that something occurred, we can check in with the ISP. Whenever we deem it appropriate to remove those prepins, we can do that. But at no point in time are we taking down the BGP session or things like that. We're just influencing our routing automatically from the router itself instead of from our engineers. So I mentioned 1111 does a lot of business in IaaS. So our team is very familiar with VMware. We deal with VMware every single day. This deployment workflow here is for when another team has a specific product that they're trying to sell. It gets passed to us for creating the VMware environment for that. So we build the network stack on the VMware side and then hand that off to the team that requested it. So we have several of these a week, and I think the fastest I ever got it down to is 4 hours for one of these deployments. That was like me going, I had a really good day, and I got it down to 4 hours. We get these down now with our automation to 15 minutes, and we have, like I said, we have multiple deployments like this a week. So being able to push this on your lunch break instead of like dedicating your entire week to it is a huge win for us. So like most of our automation, we have to define the initial requirements. Autonet, based off those requirements, will go and deploy router and switch configs for us on the back-end networking. And then on the front end for VMware, it'll go deploy things like the DV port group in vCenter, the external and org networks in vCloud Director, the NSX Edge firewall, things like that. Once the NSX Edge firewall is deployed, it'll go and configure NAT, firewall rules, VPN tunnels that we need for management and all of that. And then it will go and deploy the other side of the VPN tunnel in our firewalls and bring the VPN tunnels up for us. And at that point, all we're doing is providing initial requirements and then QAing it and handing it back off to the team that requested it. Before I go into major issues, I see I have 8 minutes left. So if you have questions and you want to queue up, now is a great time to do that. So major issues we deal with right now, we're customer focused, so deviations are a big one for us. Customers have extremely unique requirements. Some of our customers bring in really simple networks that are no-brainers to us, and some of our customers bring in the nastiest networks I've ever seen. But that deviation adds complexity to our automation infrastructure because that's stuff that we do have to plan for. We can't just tell a customer to, deal with it. We have to make sure that we account for these things. And so that added a lot of overhead to our programming here. The way we solve for this right now is trying to write as specific as code as possible. So we want all of our pieces of code to be modular and extremely specific. So at any point in time, when we're doing a deployment, we can put all of our normal tasks in there, and if we have a deviation for a customer, we can slip that in and have that run so that we account for the things that we know we need, and then the additional one-offs from the customer. Double the skills, half the focus. I did not appreciate this one until we were like already had all this rolled out, and it didn't really hit me that we needed to turn our network engineers into software developers. So a few of us came with software development experience, but the vast majority of our team did not. So having to ask them to go from 100% network engineer to, hey, 50% of your time is now dedicated to network engineering and the other 50% is dedicated to software development, that's a hard ask for your team. And it's also, it takes down your production, right? Like if you had people operating at 100% towards your network operations and now they're only operating at 50%, you have to solve for where that last 50% went, right? So our fix for this was really hammering in a team mentality. If somebody is really good at programming, great, good for you, but it doesn't mean anything to me if you're not bringing your team with you. So we really pushed the culture that if we're all going to do this, we need to buy in on a team first mentality, and your team just has to be relentlessly eager to improve every single day. I'm going to go through these improvements real quick because I'm short on time. The number one thing we're working on right now is refactoring to make Autonet our single source of truth. This is very obvious to me now because of hindsight, but at the time we went with Prometheus. So a big lift right now is refactoring to make Autonet our single source of truth. I wrote network as code, but the design as code is a really cool idea for me. My team and I have already started talking about how we can use that. So this might shift a little bit from network as code to design as code, but that's one of the main things we're focusing on. And then if you were paying attention, one of the core concepts we had was no mistakes. And then at no point in time did I mention anything that we did to address that. So we completely missed the no mistakes thing in our core concepts. We make mistakes, that's fine. So one of the things we're doubling back on now is a full test suite. I won't go into the details of that, and just so I can save some time here. As far as lessons learned go, another big thing that we preach in our team is making sure that we make it easier for the next guy. So if I make it easier for you and you go and make it easier for the next guy, maybe in 10 years, network engineers are going to look at this and wonder why we ever did it any other way. So I hope that y'all get something from this, and then you can make it easier for the next guy. The first thing we learned is do or do not, there is no try. So you can really easily get bogged down in the planning phase of this. There comes a point in time where you need to stop planning and actually start doing it, right? We figured we got most of the stuff settled. We're smart enough that we can adapt on the fly. Stop talking and start doing. You can't be scared to introduce automation to your network. I was probably the last person on the team that was comfortable with this. I was really scared, to be honest with you. The network was like my baby. I had worked on it for 10 or 11 years at the time, and I didn't want anybody touching the infrastructure. Even if it was something I wrote, I didn't want it touching the infrastructure. But if you're going to go down this journey, you have to be confident in the planning that you do, and you have to kind of like take that leap. You have to commit and just send it. Size matters not. You don't want to try to automate the entire infrastructure in one day. You have to take small, steady steps as you go, so that a year down the road you can look at all these small little steps that you made, and you'll have built something big instead of like we caught ourselves trying to slay these massive dragons all the time, and it's untenable having to work that way. It leads to burnout. So even making small improvements in the infrastructure is better than not doing anything. And then the biggest one for us, share your wins with your team, but share your losses too. So like for me, it takes me 10 times of getting something right before I remember how to do it. But if I mess up once, it is burned into my brain. And so use that to your advantage, right? Every time that we fail, we go tell our team about it. We dissect it. We understand what happened. And we got to the point where we're like really excited to tell the team when we messed something up, because we knew that we were going to be teaching them and they wouldn't have to make the same mistake that we did. Okay. Sorry, I'm a little over in time. Questions?
Jordan Markley, it sounds like you guys made a lot of progress in a short amount of time, and you mentioned upskilling and stuff like that with your team. I was wondering if you could comment on some of the most effective resources for upskilling for your team, and then also resources for that culture change on your team.
When you say upscaling, you mean like teaching them software development and things like that? Mm-hmm. So one of the really cool things we did is we did Automation Friday. So every Friday after lunch, for 1 or 2 hours or so, we would just get everybody on a screen sharing session, and then either myself or one of our other more experienced engineers would just start coding, and we would just do shadow sessions, and it's open to, if anybody wants to ask a question, we will stop and we'll just talk about that question for 2 hours if we have to. It was this buy-in on, hey y'all, this is happening, you're not doing it alone, we're here to help you, and I will sit there and hold your hand as long as it takes because I'm not going to let you fail. Resources for that, I don't know. That was an internal motivation thing, I guess. It was an idea we came up with. It made sense, so we kind of just ran with it.
Hi, Mahesh, and Garrett, thanks for this talk. I think it's timely for people who are just wanting to get into automation. I'm curious why you chose Jira to track changes and not something like Bitbucket or maybe even Git to do that.
Yeah, it was a legacy system for us, so we kind of inherited that system, and instead of reinvent the wheel at the time, we just went with what was already there. I do agree that a better place to do that is in a version control system. I 100% agree. The decision was purely based off of, hey, we already have something that's doing that. We don't need to address that right now. Let's tackle the bigger problems first.
Excellent slides. May the force be with you. Our team in San Jose used to have this struggle. The team is software engineering team, and that's actually my question. Is your force be your test cases? I guess you learn in the end of your slides, right?
Yeah, can you say the question again? Sorry.
Yeah, I guess the question is, what is your force in the end or at this moment? Is that your test cases you're gonna build?
What is my force?
Yeah, so you're saying you need more tests.
Yeah. I mean, it really is. We talk about this on the team all the time. This is like the coolest shit you will ever do in your job, right? So we really want to make sure that we enjoy it, and that internal motivation and the fact that we all recognize that this is really cool stuff is what drives us every day, really.
That's a great place to stop.
Okay. Do you want me to answer?
Sorry, last one. I was going to say, do cool-ass stuff with cool-ass people. That's my mentality.
There you go, yeah.
The question I wanted to ask, and it's probably the dumbest one of the day, but what is Autonet?
That's just the name that we came up with for the centralized server that does all the orchestration for automation.
Okay.
We just called it Autonet for the reference before we heard about AutoCon.
Okay, but is that like Python, Ansible, or is it
Yeah,
kinda
yeah.
all
Oh,
the
yeah.
things?
I'm sorry. Yeah. It's a Linux server, and we do everything through Python.
Okay, cool. Thanks.
Yeah.